start the recording and then recover that. Okay, so this is the city temperature data set that you're going to be working with over the next couple of days for the hack activity. So, as I said, our brains are incredible pattern processing devices. What is your first thing you notice from this data or from each of the rows here? Anything in particular that jumps out at you, or that you think that's a bit odd, or I need to understand more about that? Extreme temperatures from Emmanuel. The first average temperature. Okay. So we're talking about Algiers. Does anyone know where Algeria is, or Algiers? My geography is not brilliant, but it's in Africa. So North Africa. Thank you, Alistair, for pointing out, and Benjamin. So we're talking about North Africa, but even still, on the 1st of January 1995, 64 degrees centigrade would be quite a high temperature. What could explain a 64 being the average temperature? A wildfire, perhaps? Yeah, maybe. Glenn, we'll talk about 1995 as the year. So we're going to, obviously it will have been affected by climate change up to some point, but not quite to that extent, I would suggest. Let's go for a different country. If we move past Africa and Asia into Europe, let's go, okay, France, Paris, 62 degrees in 2019. Do we think it was 62 degrees centigrade in Paris in the 1st of October, a couple of years ago? That's it, Benjamin. You're on the right money there. Is it Fahrenheit? And it certainly is. It's in Fahrenheit, not degrees centigrade. So that needs to be sorted out so that it's easier for us to understand and work with the data. Either we need to stick with Fahrenheit and get our brains used to working in Fahrenheit, or we'll just convert it to centigrade and then it's much easier to work with. So as you can see, we've got this data going back from 1995, and you'll see where it goes up to through the analysis that you do. The actual activity for you to do is, in your groups, you've got to come up with a research question that you want to answer from the city temperatures data set. So you need to have a look at the city temperatures CSV data set in Python or in Excel if you want to, but Python will be much better because you can actually see all of the data in one go. And then investigate the data using the tools and techniques that we've covered over the last few days. You've got some assistance from the teaching team as we'll drop into the calls tomorrow throughout the day. But you could choose whatever research question you want, and it's entirely up to you. I've got a couple of example questions here. So is the year-on-year change in temperatures in African countries greater than European countries? Which countries exhibit the same annual seasonal temperature profiles? Or which continent has the countries that observe the largest variance or range of temperatures? Okay. Or, any question, you can focus on specific countries that you're interested in, or regions, whatever you want to go for, really. As a group, your submission has to be in by Friday, 11 a.m. You email it to the mscai@bcu.ac.uk email address, and I'll remind everyone of that later on and close to the deadline as well. And I want 5 PowerPoint slides covering your research question, how you went about answering the question, what tools, techniques, and things did you use? Was it a supervised learning or unsupervised and exploratory analysis that you were doing? Was it a regression or a classification problem? Think about the tools, techniques, and the terminology that we've been using over the last couple of days. What the results were of your analysis and how you could improve it with more time or more understanding with AI. We'll announce the winners in the 2 p.m. session on Friday afternoon, and we're going to be joined by the PVC, so the Pro Vice Chancellor of the School of Computing and Engineering. So Professor Hannah Shah is going to be coming to present the winners and announce who's won based on the submissions that we receive at 11 a.m. on Friday. Now, I appreciate there's potentially some questions about how you do this. So in the day 3 files that I've shared, the link to is a Python notebook, and it's Python notebook 3C, Hack Day 1 Basics of Python. So it's got the same name as the file that I covered with you yesterday morning. That's because it's the first part of the file has exactly the same code. Then it moves on to working on the city temperatures data set, because I wanted to have it all in one place so that you could see the early code to know how to do some of the basic operations and things that we did and then before, but how you can adapt those to the city temperatures data set. Now I've uploaded, by clicking the upload button, I've uploaded from the day 3 files the city temperatures.csv file. Okay, it's 140 megabytes. Okay, it's quite a large file to be uploading and working with. So first, if you upload it, you'll see its name appear at the bottom and a blue circle showing you the progress of the upload. It takes about 5 or 10 minutes depending on internet connection, so just give it time to finish uploading before you start working on it. So as I mentioned, the actual code here is the same as what was covered before yesterday morning. So we've got the hello world, the addition, the lists, the dictionaries, the functions that we did, the simple things, the Hubble data exercise where we're working with a pandas data frame. And that's how we're going to be working with the city temperatures data frame as well. So it's all the stuff that should look familiar based upon what we were doing yesterday. Then we get to the end and we have another data manipulation with pandas. And this, you've got a copy of all of this, and I'd encourage you to start with this as your starting point and then change around what I've done to suit your research question that you're interested in. So the first thing it does is loads in the data. And you can go through and run each of these, but I've already run all the code. Now there's a video, the latest video in the Hackathon playlist that I've shared is me walking through line by line what this code is doing and explaining it all. I don't want to waste everyone's time with this because some of you have got a really firm grasp on the code and really comfortable, and others are going to need a bit more time to go through that, so you can watch the video and refer to that. And I just want to give you the chance to talk amongst your group, start thinking of a research question, get on with it really. I want to get out of the way of preventing you from actually doing the work. So here's what the data looks like, which the head of the data, which isn't a big surprise given the Excel sheet we've just looked at. I've looked for null values and just done some standard exploratory analysis. Okay, now notice that the mean temperature seemed to be a bit unusual. So did a plot first of all and saw I was focusing on Vienna as the city in particular. So I plotted the data for Vienna and noticed that it was a really low value for 2020, which was a bit weird. So when we investigated that and plotted the data for 2018, 2019 and 2020, half the data was missing for 2020. That's because just the data set finished partway through 2020, I believe in about March time. So any analysis you're doing needs to be considering that fact that you can't go up until beyond 2020, January 1st, 2020, because you've not got complete data to go there, unless you want to try and predict what's going to happen in 2020 based upon what's been happening recently in 2018 and 19. But that's up to you if you want to choose that research question. You'll notice there's some really low values here as well when we plot the data for the average temperature that's been converted to degrees centigrade by a function that we've got just up here. And again, you can watch the video that explains that in detail, what I did there. So we've got some really low values. And when we just print out those values and check they're not null values, they're not NA or not a value or anything, they're just really low values, less than -20. I don't think it was less than -20 in Vienna, particularly I don't think it was less than -60 on those days. So we've got some bad data in there, which is entirely normal for a data science project. So what do? Well, we go and look at it. And if we look at the exact same value as recorded, -72.8, bit weird. What that actually is, it was in Fahrenheit, -72.8 converts to -99. So it's an error value. They've just put -99 as an error code. And I'll show you how to drop that or just remove it from the data, or to fill it in with the mean value or the median value, so that we've got filled in and more realistic values for the data. Instead of our -72.8, we've put in a 6 and a 9 that's motivated by the data. Then we've got the data for 2018, which for Vienna, I'm ready to start analyzing now, depending on what my research question is. I appreciate that's been a bit of a whistle-stop tour of that exercise, but the code's all there for you. You can watch the video and go through that. Most importantly, get into your groups, join those Teams links that I've sent you, and start thinking about what your research question is and how you want to go about attacking that problem, whether you want to all work on one Colab file and share that. And you can share a Colab file by clicking share notebook and giving people editor rights and things like that. Or you can, sorry, I believe I've stopped sharing there. So I'll just reshare and show you quickly where that is. So if you go back to Colab, click share in the top right, then you can share and give access to people with the link, or share it with specific email addresses, and then they can edit the Colab file alongside you, so you can, as a group, contribute to the same file. Does anyone have any questions? Okay, that's all good. So Alistair, you will have tutors dropping into the session tomorrow throughout the day, but into your groups, if you want to go into your groups now, then you can start to talk about what the research question might be. You can drop a question in this chat, and I'll try and keep an eye here and there on it this afternoon amongst other meetings that I've got. No, Andre, you don't choose the group, so you should have been sent a link. If you haven't been sent a link, send me an email to ian.rice@bcu.ac.uk and I'll add you to a group. Okay, thanks, Benjamin. I'll add you now. Okay. Good luck, and hopefully you have some fun working with the data and getting to work alongside each other and understanding a bit about each other's experiences and what you're looking forward to about coming onto the course as well. Okay, thanks everyone, and I look forward to seeing your submissions on Friday morning.